everyone, my name is Si Cheng. Today our group are going to present interference testing. Interference testing is one type of multiple well testing. So what is multiple well testing? Testing involves one larger radius of investigation than a single well. It also requires one producer and one or more observation well. Multiple well testing are not affected by skin. Skin will only affect the active well, except fracture well behind negativity skin. Well storage effect of multiple well testing are maximized. The objective of studying interference testing is to obtain permeability and also porosity. Now let us assume that there is one producer and one observation well in an infinite reservoir. The observation well does not produce. Producer and the observation well are separated by a distance r. The effect of producer in an observation well is given by the line source solution. Interference tests are run to determine reservoir connectivity, directional flow pattern, reservoir porosity, and also nature and magnitude of an anisotropic directional reservoir permeability. Thank you, and now I'm going to pass my floor to Nick.
Thank you very much, Si Cheng, for the explanation. For my part, I will explain to you one of the cases the interference testing can be done. Case 1, where the active well is producing or injecting. The pressure at the observation well can be calculated using this formula. PWS equal to P1HR plus M log T, where PWS is the stabilized well pressure equal to pressure at 1 hour plus M is the gradient log time. For this formula to be applicable, the value of 0.002637 times K times T over porosity times mu times Ct times R square must be greater than 100. To calculate this value, we must first plot a semi-log graph using the obtained data where P against time. From this graph, you should be able to calculate the gradient M of the straight line region. Next, you can calculate K or the permeability using the equation 162.6 times the flow rate times mu times B over the gradient times H. After that, you can calculate the porosity by using the formula of K over mu Ct R square exponent Pi minus P1HR over M minus 3.2275. From this formula, you can obtain the porosity. Now you have all the value you need. You have the permeability and you have the porosity. So you calculate for the value of 0.002637 times the permeability that you have calculated times time over porosity that you have calculated times viscosity times total compressibility times the radius or the distance square. If this value is greater than 100, then only you can use the formula PWS equal to P1HR plus M log T. So for P1HR, you just simply take the pressure at 1 hour from the graph, and for M, you use the calculated value you have obtained just now. And that's how you find the stabilized well pressure at the observation well after a time t. Now I will proceed to my friend Naim, so he will explain to you about the case 2. Thank you.
Here I will explain about the case 2, where active well is shut in after producing for time Tp. For this case, wellbore pressure during shut-in can be calculated using this formula. Pressure equal to Pi plus slope multiplied to log Tp plus delta T over delta T, where Pi is initial pressure. From this formula, we can calculate permeability and porosity. To calculate permeability and porosity, first we must plot pressure versus Tp plus delta T over delta T. And then, from this plotting, it will yield a straight line, where from this straight line, we can get a slope. From the slope, we can calculate permeability and porosity. For calculating permeability, we can use this formula. Permeability equal to 162.6 multiplied to flow rate, multiplied to viscosity, multiplied to formation volume factor, and then divide by slope, multiplied to height. For porosity, we can use this formula, where P at 1 hour is obtained from the semi-log straight line at delta T equal to 1 hour. After this, I will pass to the next presenter, Anis. Thank you.
Now, for my part, I will be explaining on how to do interference tests using log-log type curve. So for the first step, what we need to do is we need to construct the table of delta T, time, and delta P, pressure. So sets of data will be provided for delta T, and we need to calculate delta P using this formula, which is delta P equals to initial pressure minus the bottom hole flowing pressure. So next, after all data are complete, we can now plot the graph of delta P versus delta T on the log-log graph. It would be easier if we draw the graph on a tracing paper. So for the third step, we can now match the points on the graph to the log-log type curve. So as you can see here, this is an example of the interference test analysis type curve matching. Next, after the points are matched, we will be able to obtain match point from both of graph, which are PD, dimensionless pressure, delta P, delta T, and lastly dimensionless time over dimensionless radius square. And finally, we will be able to calculate permeability and porosity using this formula. Thank you. Now, I'm going to pass to Fabian to further explain about the interference test.
Hello everyone, I'm Fabian and I'm going to explain about the procedures in calculating permeability and porosity by using the interference test analysis type curve. Basically, there are 4 steps needed to calculate permeability and porosity using the type curve, so let us take a look at all those 4 steps. For step 1, we need to plot the delta P and time in a log-log graph. Bear in mind that the values of the unit need to follow the field units. For the second step, match the field data to the master curve with the plotted graph. When matching the curves, we also need to adjust the size of the graph to the master curve. The scale and the size of the squares need to align perfectly with the master curve to obtain the best results. The step 3 is the picking the match points from both graphs. To make it easier, pick the intersection of the squares of your plotted graph, and from there, select the respective matching points from the master curve. Jot down the values of each matching points. Delta P and T are from your plotted curve, and P and T d square are from the master curve. This is how the master curve looks like. After all the matching points are obtained, we can now proceed to step 4, which is calculating the permeability and porosity using the given formula. For permeability, the formula is as follows. After we calculated the value of permeability, we can proceed with the porosity calculation. And the formula is as follows. When calculating the values of porosity and permeability, you might get a different values than the other. It is because when picking up the matching points, each person pick different values. and the ratio of PD over P and T over TD over RD square is different. If this case happens, I believe that the acceptable difference is about 5 to 10% from the original answer. Now that we have gone through all the 4 steps, let us take a look at the example. Here's the example given. As we can see here, in the interference test data, the time and pressure given starts at 0. We can ignore these values since we are going to plot our graph in a log-log scale, because log 0 is undefined. We can also see here in the data, the last points in the given pressure data is stated as N. We can also ignore these points, along with T equal to 48 hours, because we can plot this data. So from all the 6 points given, we only need to plot 4 of them. Okay, now let's solve the example step by step. For step 1, plotting the graph in a log-log graph. This is the plotted graph we obtained from the data. For step 2, matching the plot with the master curve. As I've said earlier, we need to adjust the plot with the master curve. Here is the adjusted plot. Now that we align the graph accordingly, we can proceed to step 3, picking the matching points from both graphs. Here in this example, I picked the intersection points from the graph that I plotted, which falls on the yellow circle. As we can see from the match, we obtain the following values. These values might not be exactly the same as from the original match, but it is good enough. So from the matching points, we get delta P equal to 100 psi and PD equal to 0.92, while T is equal to 10 hours and TD over RD square is 0.85. We take these points and proceed to step 4, which is calculating the permeability and porosity. Using the given permeability formula, we only need to put in each values inside as follows. And we get the value of permeability to be 4.91 millidarcy. We use these values of K to calculate the values of porosity using the following formula. Just put in all the values inside the formula and we get the values of porosity. The values of porosity we obtained from the calculation is 0.085, which equals to 8.5% of porosity. So basically, we have solved the example using all the steps given. Well, that concludes our presentation, and thank you for watching.